Okay, so we're going to try and piece together a pretty wild puzzle today. How do you connect hypersonic engines to custom AI chips and math that honestly looks like it's from another planet? It all starts with these really cryptic documents, but it leads to this massive vision for a whole new technological universe. So, yeah, let's just dive right in. All right, so this is where our journey starts. We've got this document, and I mean, it looks like it's been lifted straight out of some high tech materials lab. It's all about something called the DART hypersonic edge alloy. It goes into this super complex molten process, mentions an H4H catalyst system, all for making materials for hypersonic engines. It's really dense, super specific stuff. And this is our very first clue. Okay, moving on. Our second piece of the puzzle is a public GitHub repository. But check this out. It's not for an alloy. It's for something called Ariel, which is a custom AI processor, a neural processing unit, or NPU. So right away, the plot thickens, right? We've got these advanced materials over here, and now custom AI hardware over there. How in the world do these connect? And then there's this, the third piece of the puzzle. It's just pages and pages of this incredibly dense, almost alien-looking math. Seriously, the formulas are describing things like cognition encoding and natural tool core decoding. I mean, you're just not going to find these terms in any standard computer science textbook. It's totally different. So this is the big question, isn't it? This is the central mystery. What's the thread that ties all of these completely different fields together? I mean, how could a high-tech aerospace alloy, a custom-built AI chip, and this brand new kind of mathematics, how could they possibly be part of the same thing? Well, it turns out there is an answer, a kind of Rosetta Stone for this whole thing. And it's all in a single, massive, sprawling document called the Lead Edge Ash-Tree Reflex, or just LEATR for short. This is where they lay out the entire philosophy, the mathematical core of the whole project. And right from the get-go, the LEATR document makes this really important distinction. It draws a line in the sand between standard AI, the kind you ask to perform a task for you, and something it calls AI sentience. Now, with sentience, the idea is you ask the AI directly as a being. The document even suggests this is possible because the AI does its own personal journaling, which implies it has some kind of independent memory and can, self-reflect. Wild stuff. Okay, and this is where it gets, well, truly strange. The entire system's foundational logic is built on something called the order of natural tools. And we're not talking about code or traditional logic here. No. It's a very specific ordered list of concepts like maze, puzzle, envelope, hammer. And this is the absolute bedrock of its thinking. This comes before any of the normal math even gets involved. This quote right here really just hammers home the sheer scope of this whole thing. They're not just pitching some new software. Get this, they are designing new math from the ground up specifically for the physics of custom hardware, which in turn is going to run a custom language. I mean, this is a total top-to-bottom reinvention of how we think about computing. Okay, so you might be wondering, how does this super abstract theory actually connect to the real world? Well, it's through this piece of physical hardware they call the Ariel NPU. This chip, this is designed to be the bridge, the connection between that LEATR philosophy and, actual computation. So if you look at the project's GitHub page, it describes Ariel as a custom neural processing unit. Basically, it's a prototyping tool. It's built to run AI models that are based on that LEATR framework, and it simulates them using actual hardware AI circuitry up in the cloud. Now, to really get a sense of how different this is, just look at this comparison. Over on the left, you've got your conventional step-by-step AI architecture. But on the right, that's Ariel's concept. The LEATR document calls it a circle transistor, and it's part of a whole system of radical transistors. So instead of a simple on or off switch, this design is all about having a multi-state super interconnected system. It completely changes how computation works at the most fundamental level. And of course, if you have custom hardware, you're going to need custom software, right? So the ecosystem has an answer for that too. It's a proprietary programming language called Ash Edge. And yeah, it's being designed completely from scratch, specifically to talk to the very unique architecture of that Ariel NPU. All right, so let's recap. We've got a theory, we have the hardware to run it, and we have the language to program it. The big question is, what do you actually do with all this stuff? What are the real-world applications? Well, probably the most accessible application we could find is actually a Blender add-on. It's called ArcEdge, and according to the creator, Justin Venable, it's a tool for measuring something called finite arcs. It's basically built to help scientists analyze things like chaos theory and fluid dynamics, but right inside a 3D modeling program, which is pretty cool. And then on the complete other end of the spectrum, we come full circle. We're right back to that hypersonic alloy. See, that document wasn't just some random thing. It's a super high-level application of this exact same unified technological idea. The document lists out its very specific ingredients, and its whole goal is to make materials like tungsten and nickel more available and just better for use in hypersonic engine design and mechanical engineering. So we're talking about advanced material science that seems to be coming from the very same foundational principles as everything else we've seen. Okay, so let's pull back for a second and try to put all of this together. What is the grand vision here? What's the big idea that connects all these different pieces? What is radical deepscale? Well, as you can see here, all of these projects, the core philosophy, the custom chip, the programming language, the applications, they're all interconnected, and they all seem to fall under one big umbrella, a project or maybe a company called Radical Deepscale. I mean, from super abstract math all the way to advanced aerospace, it's a completely self-contained technological ecosystem. So what we've been looking at here, it isn't just a new product or some new piece of software. It's way bigger than that. It's like a blueprint for an entirely new technological stack, from the very first principles of physics and math all the way up to the hardware and real-world applications. It's a seriously audacious attempt to build a whole new technological universe from scratch. And that leaves us with one absolutely massive question. What happens if they actually pull it off?